Yeah, so I'm really happy to present Michele Starnini, fellow at the ISI Foundation, Italy, and researcher in physics, right? Also worked in different applications. And I know Michele's work from random walk theory, honestly, and I was really happy to also find some other works, recent ones, which he did, and I'm happy to, yeah, to 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 suggest to start basically and share your screen.
Sure. So, hello everyone. Please let me know if you cannot see my screen because something deeply wrong is going on, but I think at least you
Good.
both can see it. Good, great. So, thank you very much, Lyubov and Mark, for this invitation, and thank you all for being here today. Hope it's going to be fun. Today is going to talk about echo chambers and polarization dynamics on social networks. So no random walk theory because it's late, it's 5 p.m., so we want something lighter. Okay, so yes, so my background is in physics, actually, statistical physics, but like now I work at ISI Foundation, so I moved a little bit toward network science, computational social science, and so on. And this is more or less, let's say, the field of the seminar today. So let's start with business. Let's say that today we're gonna present several works divided mostly in two parts. First part is about data, right? So it's about what are these echo chambers, how can we measure, how can we define them. Then of course the second part is about modeling, right? So the data tells us a bit what's the story, what's going on social media, and then with the models we try to understand how these phenomena can arise, right? Can emerge. Okay, cool. Let's start with the first part. Okay, so echo chambers. Let's start with the very definition of echo chambers, right? So now the point is that echo chambers are quite an interdisciplinary topic, and they've been addressed by different research area, right? So physicists, network scientists, sociologists, political scientists, computer scientists, and so on. So let's start with a broad definition that is more or less widely accepted by everyone, which is echo chambers, a situation in which one's belief or reports that you will be in interaction with other peers that share the same opinion, the same point of view. All right, and that's not a problem in principle. The problem arises if your opinion formation is influenced by other opinions, and in particular on social media. Because as you can see now, about 2/3 of Americans get news on social media, and so if you form your opinion in this environment where you see just part of the story, then of course your opinion can be biased. And there are several papers pointing out echo chambers as the reason why, for example, misinformation can spread online, or the fact that fake news and so on, different topics, different media, of course. Now, the picture is not completely clear, and there is a lot of debate actually among researchers about this topic because, of course, echo chambers can be topic dependent, sorry. So the idea that for different topics, maybe different dynamics is going on. And then, of course, there is the idea that people do not follow don't get their information just from one source, but they follow different sources, right? And so, some researchers arrived to the conclusion that you should avoid echo chamber about echo chamber. All right, so what's going on? Let's try to understand it a little bit. So since my background is in statistical physics, I like quantitative stuff, right? And what I like to do is start with very simple definition and then try to measure these things around here, right? So, okay, so definition of echo chambers, we need two key ingredients, right? The first one is that we need opinions of people, opinions of users with respect to some controversial topic. Right, for example, politics or vaccines or whatever you want. And then, of course, you can try to measure which is the distribution of this opinion in the population. You will see that the opinion, for example, is polarized. Then there are different ways to measure opinions of users, and we'll get that back soon. So this is the first ingredient. The second one is the network structure. So, of course, on social media, users interact, and then you can reconstruct some kind of social network among these users. And the point is that for echo chamber to exist, you need the presence of some homophily between these users. Now, the key point is these two measurements should be independent, right? So I want to measure in some way the opinion of the users, and then in some other way to measure the network of interactions. Right. So let's start with a simple case study. So with a single example, and for example, politics. We love politics. We start with a very polarized event in 2016. I don't know if you remember, but the impeachment process to the former Brazilian president Dilma Rousseff was a very participative event, in the sense that the Brazilian society was split among two groups of people. So one group of people was supporting the impeachment, and the other one was against the impeachment, sustaining that there was a coup d'etat. All right, so what we did is to collect data, basically. So we collect 12 million tweets in 2016, and based on some sort of keywords. So keywords are here in Portuguese, of course. Then what we did is try to reconstruct which is the opinion of users through the hashtag they used. So basically, we manually not myself personally, but 4 independent reviewers classify these hashtags, and they classify tweets with some sentiment. Of course, this is not perfect. Nothing is perfect, because hashtag, as we know, can be hijacked. I can use an hashtag with the opposite meaning of what was intended for. But still, this is an approach. There are so many hashtags that we hope that more or less there was agreement among the reviewers. And so more or less what we got in the end is 2 quantities for each user. So one quantity is simple, their activity, the number of tweets they sent in this year. The other one is their leaning, which is basically the average sentiment expressed through their tweets. Then, of course, the activity fluctuates in time enormously, depending on the events that were going on. Like there were street protests and like very big events going on that year. And also the polarization of the system was fluctuating in time, of course, depending on these events.
Michele, I'm sorry.
Sure.
Can we do questions while you are talking?
Yeah, sure, of course. Please.
So what is a leaning exactly?
The leaning here is defined exactly as the average sentiment of the tweets of the user. So if I send 10 tweets, which are 9 positive and 1 negative, positive and negative here we just refer to the sentiment toward the impeachment, right? So positive is if I support the president, negative if I don't support it, for example. And then the sentiment is uniquely identified through the hashtag. Then my leaning will be like, for example, 0.8, right? So the leaning is between -1 and 1. It's just a number that classify me in this spectrum of political, let's say, orientation. Okay, so just a number.
It's a sentimental number.
Excuse me?
Sentimental number, quantification.
Yes, exactly. This number is represented actually here. Here in this plot on the bottom left of the slide. You can see how this sentiment, this leaning of the user is distributed between -1 and 1. And you can see there is this big bimodal distribution of the leaning. So there are a lot of people strongly in favor of the president, of the ex-president, and a lot of people with strong negative sentiment. But there are no people in the middle. So this is the idea of polarization, right? We have 2 opposite sides which are fighting. Okay. Note that there were also neutral hashtags that have been used, classified among the hashtags we classified. There's another very interesting feature, which is that actually not only the system is polarized, but also the users which are more active are also the users who show the strongest opinion. And this is the plot on the right. So if you look at, so this is not just the PDF of the leaning, this is the correlation between the activity of the users and their leanings. So if I send a lot of tweets, that means that I'm strongly polarized, one side or the other, but I'm not neutral. This is interesting, and we will come back to this further in the talk of today. All right, now networks, the second ingredient, right? So here I'm going a bit quick on this because we are all familiar with networks, Twitters. You can reconstruct the network of mentions between users. So I mentioned you want to say, hey, let's go to this street protest today. We reconstruct the temporal network, which means that we take into account the timestamps of the interactions, and plus we extract the strongly connected component of the aggregated static network, but we keep the temporal dimensions. Okay, and the idea is that you want to preserve time-respecting path for information diffusion, which is something we're gonna learn in a moment. This is the result. For example, this is like the aggregated version. Of course, you color the network depending on the leaning, and this layout is independent of the color. That was the thing I want to say. So the two measures are independent. The leaning is strictly to the tweets, and this is just the network of interactions, right? And here you can see that the community structure is also strongly polarized. There are some communities whose leaning is strongly positive, and some communities with leaning strongly negative, but very few communities and small communities with neutral leaning. You see, there are no communities with zero leaning, right? All right, so how can we measure these echo chambers? So two things. First one is the homophily in the social network. So if you look at, for example, the correlation between the leaning, my leaning, and the leaning of my neighbors, the leaning of the people I'm interacting with, okay, then you can see that this is not randomly distributed at all. So people with positive leaning interact only with people with positive leaning, and vice versa for negative one. So these two blobs, the yellow ones, these are just density plots, right? This is telling me where the users are in this map, right? And this tells you that actually all the users are completely split into two groups. Positive users, positive users with positive leanings only interact with people thinking like they think, with the same opinion, and the same for negative ones. Okay, so there's a strong network segregation, and this is like the first measure of echo chamber. Second one, as I told you, information spreading. What happens if one wants to simulate some kind of information spreading on this network? Okay, so let's use like the standard SIS or SIR process. So in the sense that each node, each users can be aware or unaware of some information, then if two users are in contact, then the information can spread through the network. Just a standard SIS model, epidemiological model, but for information diffusion. What happens here? Well, fun things. We can calculate two quantity, for example, the spreadability of the users, which is simply the number of people I can reach out if I send some information in the network, the reachability of the users, which is the probability that I'm reached from some information which is spread from some other users, okay? Now, if you plot this spreadability of reachability as a function of the activity and the leaning of the population, you will note something interesting, which is, of course, the more active you are, the more users you reach, and this is expected, right? Or the more active I am, the more the more I can be reached from other users, and that's fine. But then you can see that this spreadability is not constant with respect to the leaning, which means basically this: if you cut this plot horizontally, like in the line like this, okay, you will see something interesting like this. That is, the number of users that are reached that depend on the leaning. So in this case, for example, the users with negative leaning reach much more users than the positive ones. And more importantly, if I ask myself, but which is the average polarization, the average leaning of the users that I reach? That is, if I send a message, let's say, hey, we need to impeach Dilma, or I don't know, some political message, which is the average leaning of the users that I can reach? Well, this is like the green curve here that tells you that there is a strong correlation between my leaning and the leaning of the people that I reach. So this is the second measure of echo chambers, if you want. There is a bias in information diffusion, because the information that I spread through a network do not reach everyone. It only reaches the people that thinks like me. And this is like the second ingredient of the echo chambers, okay? That's it. So basically these two ingredients, these two quantities, so the bias in information diffusions and the homophily in the social networks, we found out that they are present in this case, like the Brazilian impeachment of Dilma Rousseff. What's going on with different topics, different social media? That's what we did in this paper. We did a cross comparison across different social media, so Twitter, Facebook, Reddit, and Gab. Now, the interaction mechanism is different. So we take, for example, co-commenting on Facebook and Reddit, and on Gab as well. On Twitter, you take the following relationship. And then, of course, the method to collect data is a bit different, because on Facebook, we rely on different pages with respect to different topics. So, for example, on Facebook, we took like the vaccines or the science versus conspiracy pages, and we look at the users that were like interacting through commenting posts on these pages, right? On Reddit, we took different subreddits. So, for example, the Donald or politics or the news, and then we reconstruct the tree of comments for each subreddit, and we look and reconstruct the social network interaction in that case. On Gab, we took the whole Gab network, which is like so Gab is like is a alt-right, let's say, forum, let's say for people generally with the right leaning in the United States. and again reconstruct the comment structure between these users. Okay. Now, how we can quantify the leaning? Now, quantify the polarization, the opinion of the users, as I said, is a difficult task. Okay, so there are a lot of different ways to do that. For example, one way to do that is to use hyperlinks to URLs of the comments of the people to some news source, which is already characterized. Sure. No, okay, no question, sorry. So the idea is that if I'm commenting something and I say, hey, look at this source, and I cite the New York Times, for example, the New York Times is classified, not by us, but from this paper actually, from this paper by Banshee and Adamic in Science, 2015, as a source of, as a source with the leaning on the left. If I'm citing, for example, Fox News is a classification which is on the right. And so I can classify users depending on the source, the site. Okay, this is not something we invented. It's something which has been done like in several papers, right? Okay, nice. So what's going on in this cross social media comparison? So here we took one topic for each social media. So we took abortion for Twitter, vaccines for Facebook, Gab, politics for Gab, and politics for Reddit, and we looked at the, for example, at the homophily in social network. Here you should see like a different picture between the two, between two classes, let's say. So Facebook and Twitter on the left, you can see two clear echo chambers, right? These two yellow areas actually are two areas of people that think like the same. So on respect to abortion on Twitter, people who are pro-abortion only interact with people who are pro-abortion, and the same for anti-abortion. Okay. On vaccine is exactly the same. So if I support vaccination, I only interact with people that thinks that vaccination are good, and the opposite with anti-vax. Okay. On the other hand, on Reddit and Gab, you can see there are not two bulbs. They're just two areas, bright areas, right? Which means that basically, more or less, people can interact with all the other people. Of course, now Reddit, you can see like this is not zero, right? So the idea is that Reddit is, here negative means left. So basically on average, on Reddit, people are more left-leaning, and on Gab, people are much more right-leaning. Okay, but you don't see this split. And this is the difference. So you see the same if you look at the community structure in these networks. You can see on your left, which are Facebook and Twitter, basically you have several communities, and each community is a clear color. You know, it's red or blue, but you don't have white communities, right? While on the other hand, on Reddit, you find only blue communities, and on Gab, you find only red communities, right? Which means that on Reddit, more or less, you find only communities with other leaning left, and on Gab, or right. Okay, what about information diffusion? If we do exactly the same, so we run a spreading model, and we look at which is the average leaning of the people reached by random users, so by some random seed of this process, you can see that the plot on the left, so Facebook and Twitter, so abortion and vaccines, you can see that there is some dependence in the leaning. So this curve, this plot is not flat, right? This means that if I spread information with respect to abortion, that it's much probable that I reach people with the same opinion on abortion. On the other hand, on Reddit and Gab, you see that this curve is completely flat, which means that no matter which is my leaning, I will reach, on average, of course, on average, people who thinks more or less always the same. Okay, last thought about this first part is about a direct comparison between Facebook and Reddit with respect to news consumption. So we took news consumption and we compare these two, all these three features, right? So as you can see here, for example, the first plot on your left is about the homophily. There's a strong homophily on Facebook because you can see several bright, let's say, areas, right? Which correspond to different political leanings. While on Reddit, more or less, you can see that all the people are concentrated in the same area. Then the communities, you can see that on Facebook, the communities are more or less split between blue one and red one, while on Reddit, the color is more or less all blue uniform, right? And then the last thing, the bias in the information. On Facebook, you see this difference, the plot is not flat with respect to the leaning, while on Reddit, more or less, it's quite flat. Okay, so this is the first take-home message of this first part about empirical data about echo chambers. So what we try to do is to quantify these echo chambers and to quantify through two different features. First is the homophily in the social networks. So which is the leaning of my neighbors? Is it similar to my leaning or not? And the second one is the bias in the information diffusion. So what happens is some information spread through this network. The diffusion is biased or not? That's it. And now we do this cross-platform comparison. We've seen that basically the new consumption on Facebook and Reddit is quite different. Okay, now the second part is about models. So now we understood, I hope you understood that more or less these echo chambers are not some abstract thing, but they can be really quantified, they can be really measured in social media. So let's try to propose some model that can capture some aspect of these echo chambers. So for example, a model of polarization dynamics. Now I will not go into details because I want to show also other things, but basically what we propose is the following. It's a classical agent-based model in which each agent I is characterized by his opinion X. X is just a number that can go to plus infinity to minus infinity, so it can fluctuate. And this is just the differential equation that determines the evolution of X. Well, so which are the main features of this model? Well, first, there is some kind of social influence. So the idea is that if you interact with my neighbors, then they influence my opinion. So how do I interact with these neighbors? Well, there is some kind of time varying connectivity, which is inspired in the activity-driven model that we'll see in a moment. Then, so how does influence work? The idea is the following. The idea is that if two agents have opposite opinion, one is blue and one is red, and they're interacting, well, they may discuss a little bit and they could converge to consensus, for example. So they could become, in the next time step, a little less blue and a little less red. On the other hand, if two agents with the same opinion are interacting, then they can increase the conviction, they can mutually reinforce each other, they can radicalize themselves. Okay, so what about the underlying network? This is the dynamics of the opinion, but what about the network? The network is also a time-varying network. It is inspired the activity-driven model, which means that each node has a certain probability to fire a connection, to send tweets, for example, to neighbors. Now, the point is that this node is not sending random tweets, but is sending messages to nodes who has opinions similar to his own. So this is the homophily thing, right? So basically, agents with similar opinions are more likely to interact. So homophily is a basic ingredient of the model. Now there is the third and last ingredient, which is that topics can be more or less controversial. And this is represented by this hyperbolic tangent here, right? So the idea is that the more controversial the topic, for example, abortion is very controversial, it shouldn't be, but still, the stronger the social influence, even for mild opinions, right? And this is tuned by this hyperbolic tangent in this parameter alpha. So basically, alpha tunes the degree of nonlinearity between an agent's opinion and the social influence he exerts, okay? So to sum up, this is the model. There are three basic ingredients. So there is the social influence, there is the homophily in the connection, which are temporal, and then the fact that the topics can be controversial. So what happens? This is what happens. Basically, the model gives rise to three different scenarios. If there is social influence, but there is no controversialness in the topic and no homophily, you can see that this is the first scenario on the left. Well, all the agents converge to some kind of consensus, right? This is the typical consensus that emerges also in classical opinion models, right? Now, if you switch on the controversialness, yes? No, okay. Now, if you switch on the controversialness of the topics, right? As in this case, you can say that agents can be radicalized. Why? And this is a second scenario, right? Radicalization. Why? If you switch on also the homophily in the interaction, okay, then you can see the split between blue and red agents with different opposite opinions, okay? So there is the emergence of this polarization in the system if the three ingredients coexist. So if you switch on social influence, homophily, and the fact that the topics are controversial, then you see the emergence of polarization. Actually, you see an actual phase transition between the consensus and the polarization. So here in this plot in the white, it's plotted like, so what's plotted here is the average, the absolute average final opinion of the agents in the system, right? Then you can see that it's zero. So basically there's consensus in some part of this plot, and it's very colored in the other, right? And this depends of the interplay between the degree of controversialness of the topic, which is this parameter alpha, and the strength of social influence, which is represented by K. And actually, you can show this by some very simple mean field approximation. So this equation that you can see here, plotted into dashed line, you can see that more or less it can recover quite well the behavior of the model, right? All right, so the last part is about comparison with empirical data, right? Because I mean, we did all the work about data and then we want to compare the model with the data, right? So we took the Twitter data about the controversial topics on Twitter, so gun control, Obamacare, and abortion. I presented it before, right? So the link is extracted through this, the link to the media source that you posted, and the reconstruction of the network is just a follow relation. So what happens? Two things. The first one is that, as I showed you before for the Brazilian case, this is this correlation between the activity of a users and his opinion. The idea is that the more active you are, the more likely you have an extreme opinion. And this is true also for the model. So on the left, you see the data, on the right, you see the model. This is this nice U-shaped form, right? So more active users tend to show more extreme opinion. And the second one is about echo chambers. So the idea is that the opinions become polarized. So on the bottom of this plot, on the bottom of this slide, you can see the three data set, right? So these two light, bright area, that means there are two echo chambers. And on the right, you can see the model. You can see that qualitatively, the behavior is quite similar, right? And also in the model, there is this strong segregation in the social network. Okay, so second take-home message is about that we actually can try to model these polarization dynamics. So if you put social influence, the controversialness of topics, and the fact that the agents can interact in a dynamic way, so they interact with the temporal evolution, with some kind of homophily, you can observe actually a real phase transition between consensus and polarization, and you're able to reproduce two features of the empirical data: the activity versus polarization correlation, and the segregation in the social network. And these are the two plots that I show you in this slide. Okay, now we have the very last part, so the third part, about what happens if you consider not just one opinion, like in this case, or one topic separately, but if you try to mix, so to understand what happens if you consider many topics at the same time. Okay, so let's start with it. So the idea we had is that basically, of course, like the most straightforward thing that you can do. So I don't have just one topic. I have, let's say, two topics. So one is, for example, is the right of same-sex couples, so homosexual persons. And the other one is the rights of transgender people. Then if you can represent them like as two axes in a two-dimensional space, right? So the idea is that each topic is a dimension of this space. Now, the idea here is that, okay, but maybe like this is a bit too much, right? Because the idea is that maybe there are topics that are more similar, more related between each other, others that are completely unrelated, right? And so the idea is that we use a non-orthogonal topic space to represent this scenario, right? So the idea here is that opinions now, they evolve into a multidimensional space, but there is a non-orthogonal basis spanning this space. So basically, if you consider just two topics, there is the angle between these two topics that can be like smaller than the pi half. That's it. And there is this topic overlap matrix, is this phi VZ matrix that tells you for each pair of topics, which is the overlap. So if two topics are completely independent, think about, then we'll see some examples. Two topics completely independent, then they have zero overlap and they are orthogonal. If on the other hand, they have some kind of overlap, such as this one, rights of transgender people and rights of homosexual people, then there is some overlap, okay? Then the distance between these opinions are calculated as start forward with the scalar product. Just now, since the space is not orthogonal, you need to add the metric of the space, and the metric is just your matrix 5. Cool. So now, again, not going into too many details, but the idea is that you take a formulation which is similar to the previous one, but now you add the ingredient that actually now the opinions are not numbers, but they're vectors, right? So the vectors in this multidimensional space. And the idea is that an opinion on one topic can also influence myself on some other topic. The idea is that if I discuss with you on Twitter or on Reddit with respect to, for example, abortion, right? then maybe you could influence me, not just with respect to abortion, but also with respect to other topics that are similar in some sense with abortion. That's it. Now we'll see that actually, if you consider that this space can be non-orthogonal, or say different in a more physical way, as soon as you relax the assumption of an orthogonal space, then you will see that there is the emergence of ideological states. Ideological state means that opinions can be extremely polarized and correlated. Okay, so this is exactly what comes up from the model. The idea is that now we consider just two ingredients. The idea that topic can be controversial or not, and they can overlap or not. So if there is no overlap and there is no topic are not controversial, then you observe consensus again, right? So all the agents, this is the plot on your left, actually the bottom row is the dynamical evolution that you can analytically derive for the model, okay, without going into details. But the idea is that if there is no controversialness, then all the agents converge to a consensus. Then if the topics, on the other hand, are controversial, then you will see polarization, right? So the idea is that, for example, you take two topics which are completely independent. There is no overlap, for example, vaccines and abortion, right? They're completely independent. Then you will have the strong polarization. Sorry, this is my cat. Sorry for that. All right, so if you take two topics, then you have polarization with respect to topics separately, right? So you can have people which is pro-vax but anti-abortion, or pro-vax and pro-abortion, all the four combinations, right? While the nice thing happens if you have some kind of overlap. For example, you take the two topics which could be like right of homosexual people and right of transgender people. Then the symmetry of the system is broken, as you can say, physics, right? So the idea is that there are some states which are not permitted by the model. The idea is that either you are for the rights of transgender people and the rights of homosexual people, and against these rights, but you cannot be like pro-rights of the transgender people and against the rights of homosexual people, right? And this is what we call ideology, right? So it's just a collection of states in which, let's say, that you have a specific orientation with respect to many topics, in which some combinations are forbidden, okay? Okay. Actually, you can say again that there is a real phase transition in the model, and the idea is pretty simple. So the idea is if you increase the controversialness of the topics, then you have a phase transition from consensus to polarization. So actually, the agents become suddenly, the consensus state is split, and the agents polarize. And then the idea, if you increase the overlap of the topic, actually, you don't have all the four combinations, but these four combinations are reduced to just two combinations. And so you have the emergence of the ideological states, right? Again, you can capture this through main field approximation, not going into the technical details, but the idea is that, you have these three different regions in the model, okay? And you have phase transition between these three different regions. Now, if all this looks like a bit like abstract, but what this means in the end, actually the nice part is this. Sorry, there's just one other slide before. Okay, so this one is about the topological, the structure of the network, right? So the idea is that as well as the opinion segregates in different, the agents segregate according to the opinion, the same segregation is reflected in the network, right? So as you can see in consensus, all the agents interact with all. When there is segregation in the opinions, in the case of polarization, there are four different communities in the network, very well identified. If there is ideology, then there is just two different communities in the network, right? And so there is this reflection of the structure of the network that reflects the opinion state. Now, what I was saying, if you think it is a bit abstract, actually it is not, because if you look at real, and this is like the last slide of the talk, if you look at real data, so if you ask people their opinion with respect to several topics, and here we took data from the NAS survey data, the American National Election Survey, that actually since like I think 1950, every 4 years, asked like a bunch of questions to people, like so many questions on different topics that ranges from, for example, if voting is a duty or a choice, Obamacare, so a lot of topics, and they measure the opinion of the respondent. And so there is something interesting, because if you compute the correlation between these opinions, because the respondents are all the same, right? So if you compute the correlation between the opinions, for example, let's start with two topics, like, for example, the use of military, or if you agree to free trade. And this is like the plot on your bottom right. The idea is that Americans, with respect to these topics, more or less can converge to a consensus. So not the military should be used, but not too much and not too little, right? So they converge in the middle to consensus. And the same is true for if they agree or not to free trade. Yeah, free trade, but not too much, right? And this is the consensus scenario that we've seen like in the model. Then if you start taking topics which are a bit more controversial, for example, Obamacare, you know that Americans split about Obamacare. Some things that it's great, some other things that it's terrible. Right, so they're polarized with respect to Obamacare. And they're also polarized, even though it could be like weird, but they're also polarized with respect if voting is choice or duty. And this is the plot on your left. So you can see this scenario with these four areas. Like, of course, this is data, so it's all very noisy. But you can see these four areas emerging in the plot, right? So the idea is that all four combinations are possible in the system, not in the system, but in the real data. You can be like pro-Obamacare and against voting, or pro-Obamacare, pro-voting. You know, all combinations are possible. Now, the interesting part, the ideology, if you take like two topics that are as unrelated as, for example, if you are favor or against the wall with Mexico, so building a wall with Mexico, remember Trump was building this ridiculous wall. Okay, so Americans are clearly split with respect to this idea. Pro-Trump supporter thinks it's a good idea, the other one thinks it's not. Then you take another topics, for example, the use so for transgender people, should they be allowed to be used the bathroom or the gender they identify with? So this is a real question that DNS asked to thousands of people, right? And also people are polarized with respect to this. So we don't expect, but also people are polarized to let transgender people to use the bathroom of their choice. And actually the nice thing is, of course, again, this is data, so it's not perfect. But you can see that there is two areas in the plot on your top of your right, two areas that are much brighter than others. So in the end, if you are favor to the wall with Mexico, you are against the right of transgender people to use the bathroom they prefer, you know? And if you are against the wall, then you are for the pro-choice for the transgender people. And this is clearly an example of ideology. So the ideology we found in the model actually is well motivated by the data. So that's it. This is the third and last take-home message I would like you to take with you. The idea is if you embed opinions in an orthogonal topic space, and you allow topics to be controversial, and they can overlap depending on how related they are, then you can observe a phase transition, actually two-phase transition from consensus to polarization, from polarization to ideology. And you can also reproduce these three different scenario. I mean, like the model reproduced these three different scenarios that you can find in real NS data. Well, I would say that that's it. These are the papers on which the talk is based. So like, last thing I would like to do is like to thank my collaborators. So Wesley Cota and Silvio Ferreira from Universidade Federal de Viçosa in Brazil, about the work about Brazilian data, and Romualdo Pastor Satoras from Università Politecnica di Catalunya. Then Matteo Cinelli, Gianmarco De Francesco Morales, Alessandro Galeazzi, Walter Cotrociocchi about the comparison across different social media. And then at last, with respect to the modeling part, Fabian Baumann, Philip Lawrence Pin, and Igor Sokolov about the two models of the emergence of echo chambers and polarization. Well, that's it. Thank you, everyone. And we're happy to take your questions, if any. That's it.
Thanks a lot. It was fantastic. I loved it. Are there any questions in the audience? Maybe either. I'll go for it.
Okay. So thank you very much, Michele. It was very interesting. Hi. So I have two questions related to the topics that you introduced, based on the matrix phi. So basically, the matrix phi is symmetric, as I understand.
Exactly, precisely.
So how can this symmetry explain what you said in the last before the end slide, that some topics are more characteristic about ideology than other topics? Because this would mean, for example, that there is a type of causation that if I am pro wall, then I will have the specific opinion for the transgender people, but not the inverse. That means that not if I have the opinion about the transgender people, would that imply definitely the opinion on the wall. So this is non-symmetric essentially.
No, actually, I mean, like, so, okay, first thing is that this topic matrix is symmetric, but also this matrix is symmetric because it's a correlation matrix, right? So, and this is why I show just one triangle here, because the other one is exactly identical, right? Mm-hmm. So the idea is that I don't know what comes first, if like a transgender bathroom or war with Mexico, and probably there is no direct causation between the two, but probably the idea there are some confounding factors, right? Beyond that. So basically, which is politics, right? So if you are right-leaning, probably you are pro-wall and against transgender people, right? Mm-hmm. So this is like the real reason for the emergence of this ideological state, right? So there is no causation, I think, so there is no proven causation between the two topics, but the idea there are some confounding factors behind that. But the interesting thing is that, and this is the part that I like, is that even between topics that there are no correlation with, I mean, like, so if you take, for example, these topics that apparently there is absolutely no overlap, because how can you overlap the transgender people with the war with Mexico? I mean, even like with respect to the topics are formulated in general, there is no overlap. But then the correlations between the opinions emerge due to this idea of, for example, the radicalization dynamics, and that the topics are more controversial, right? So this is more or less what the model tried to capture in a sense. So there's no direct causation between one topic and the other, because this matrix is basically symmetric. But it is that there is the emergence of ideology due to something else, right? So we don't investigate what is this something else, right? But it is that these states, which we call the ideological states, can emerge due to this mechanism.
Okay. Did you try to measure the inertia of this matrix, meaning how many dimensions could explain 95% of the inertia of this all these topics? What is the latent space that could explain these differences?
I cannot hear very well. There is anyone who's speaking or any question probably? Let's see, like
yes.
Yeah, can you repeat louder the question, maybe in the microphone?
You hear me better now?
Yes, that's better.
Okay. The question was, did you try to measure the dimension of the latent space that could explain these differences between topics? Meaning, if, for example, the latent space is a purely one-dimensional left-right, and of course, it's not a single dimension, but how many dimensions could explain the most of the inertia of this matrix?
That's a super cool question. Actually, yes. So actually nobody knows, right? I mean, like, how can you do that? It's very difficult. I mean, let aside all the echo chambers and polarization and stuff, but I mean, like, the very question of how many dimensions there are in the space of topics that we use to interact with, but that's not clear, right? I mean, like, you could, so the idea is that basically you could embed this opinion in a space which is latent space, which is not fixed, right? And there are two possible interpretations for this. I also like this part. So the idea is that you could decide for a low-dimensional representation, which you say, look, like, for example, I take like a few topics, and the idea is that I encode into this overlap. So this is why the non-orthogonal thing is important, right? I encode into the overlap between these two topics all the relation between the two topics. So just a low-dimensional space, and then two topics overlaps if there is some other confounding factors. But I think like a low-dimensional representation. I don't care about other stuff. I just say that they overlap if there is some kind of relation, and that's it. While you could also try to do another thing, which is, okay, let's try to include additional dimensions. So maybe it's not just these, but there are, for example, in the case of transgender bathroom and war with Mexico, could be like, for example, a third topic, which is my political orientation, right? And then of course, things will change. Now, I didn't show you in the slide, but it's in the paper actually. It's in the paper, which is under revision still, but it will be in the paper for sure. The nice idea is also that if I add, now look at this, if I take two topics which are orthogonal, but then I add a third topic which is not orthogonal with respect to the first two, so I expand the dimensions, but in a sense that I preserve somehow this orthogonality, then the correlations emerge in the same way. So the two possible explanations are true. Either I choose a low-dimensional representation and encode everything in this angle, or I can choose like a space which is larger with higher dimension, and then you obtain the same results if you still maintain the idea that the space is non-orthogonal. So actually, the question is very good. We don't know. We don't know how highly dimensional is the space we want to embed the opinion in. The idea is that with this model, I mean, like the emergence or the correlations between the different opinions emerge in both cases. Sorry. Of course, like, so let me tell you something more. Actually, this would be like a nice follow-up. I mean, like food for thought, whatever. The idea is that, like, I don't know, if we take, for example, large corpus of text, newspapers, I don't know, like discussion on forum, on social media, blah, blah, then you could try to embed, then you could try to represent this space, right? So the idea is you take all the text and you do like a standard embedding, and then the axis of your space are actually the topics, right? This is like a standard topic model, no? And so there you could measure, we could try to measure how dimensional is the space. So this is something we thought about, but it's for the future. If you're interested, actually, this work to do so.
Thanks. So I have a big picture question, but imagine tomorrow you're going to Facebook and they invite you to kind of be a board member of redesigning the recommender system or solving these issues. What would you act on? What would be your, now that you're a physicist, you've modeled the thing, now you can control the thing, right? Because you know the parameters and how to tweak them. What would be your recommendation insofar as redesigning or rethinking recommender systems or to mitigate, right, for such effects that you're showing us?
That's super interesting question, and I have no answer. I mean, like, actually, even the very, I mean, like, even about the very existence of these phenomena of polarization and echo chambers, there's a lot of debate, and like people are throwing stones at them. Like, no, echo chambers do not exist. Like, you're a liar. And so, like, even about like measuring something simple like this, there's a lot of debate. So maybe because of my physics, I mean, like, my background is quite quantitative. I like to measure stuff. And I try to do like all these works about like, let's see, let's try to give a definition and measure and see what happens. So I mean, like, about recommending something to mitigate this phenomena, we don't even agree about if it exists or not. So actually, I don't know. I never seriously thought about that, and I think it's really something that we should try to do. But you're familiar with all the Twitter story of Donald Trump now. Twitter is putting like now this meme that they put like official source that the story is different. So this is probably a way to try to mitigate, like the polarization in the system. But as soon as you do that, then people say, there's free speech. We should be like free of doing, saying whatever we want. So I think it's very delicate matter, let's say.
But Michele, the way you have presented everything until now, it seems that a very reasonable assumption would be that somehow a platform just introduces certain opinions to the people that are non-related to homophily. I mean, it's the direct conclusion I get from your talk.
I don't want to say that. I mean, like,
no, but because in a way that's what I think of as the kiosk effect, right? You might buy always newspaper from the right side,
right.
But when you go to buy in a kiosk, you're exposed to all the other sides. And what platforms don't do anymore is that they don't provide you with this little noise. So a simple way would be indeed like, what happens when you add noise in a way, like, a certain epsilon to your exposure?
Actually, it's a highly debated idea. I mean, like, there is this PNAS paper by Chris Bale, actually the selective exposure paper, about the idea that if you expose people to opinions that are the opposite of their own, you could actually increase the polarization. They did an experiment and they found out this. So like, it's very complicated. I think, I don't know, but I think it always depends on how you expose people, like, because the paper is great. It's a great paper, super interesting, but of course it depends how I'm exposed, right? Should be like some kind of nudge, not like I put it you and this is, I don't know. It's delicate. It's really, I mean, human beings are really machines that are very difficult to understand. So I mean, it's a very open debate, and to me, it's an interesting topic.
I have a follow-up question on that, actually. Because the way you define interaction now on Twitter is by follower relations, if I understand correctly, right? And or I think you had mentions in the beginning, but yeah. The way the patterns we see often in our group is that there is something like a polarization with respect to following and retweeting, but with direct interaction in replies, you don't see this anymore. Which means that in fact, when you look at the interaction, people indeed they see the other side and they talk. So I was wondering if you see something similar in your data also.
Thank you very much for this question. This is very, very interesting. So I think you're familiar with the seminal work of Phil Menser and his group, which is political polarization on Twitter, right? In that paper, there is a figure which shows you that actually the polarization is only in the follower or retweet network, but not in the mention network. Do you remember that figure?
Yeah.
I'm not here, but I use it generally. And this is precisely why in this work, the first one, actually, this is the figure, right? This is the figure of the polarization. Then if you look at the mention network, in that case, the mention is all red. So there is no split there. And this is exactly the reason why in this paper that I show you about the Brazilian network, we took the mention network. Because we said, okay, so in retweet is obvious and somehow. Let's see what happens if you really look at the mentions, right?
Yeah.
So when people really like try to talk about, because if I mention you, there is something that I want to tell you.
Yeah.
And we find out this strongly polarized network, nonetheless, you know. So.
And for the topics that you showed later.
For the topics you showed later, this was not the data that I personally collected. So yeah. It's another paper which is cited here. Wait a moment. I think it's cited here in the model. This is the paper by some computer scientist that was showing this one. So political discourse on social media, echo chambers, get tips, blah, blah. So they collected the data. In that case was the follower relationship induced by the keywords, okay? In that case was the follower. So you see like, but I mean like the pictures are really similar because if you look at these pictures, this is exactly the same quantity. Your average leaning versus the leaning of your neighbors, okay? And you see the two areas, and then you go back and you see the dimension network. Actually, the mention network in which you extract a strongly connected component and blah, blah, blah. Come on, man. Yeah, there. You see the same thing, right? At least the same behavior. So, of course, it depends. I mean, like, if you take another topic, probably, I mean, like, for example, Phil and the others, in their work, they didn't see this polarization in the mention network, right? So I'm not saying that it's always like that, but in this case, it is.
Yeah. Yeah, I think it's very interesting to see how this differs and how, yeah. Thanks a lot.
Thank you.
Maybe I had just another potential little question on your model, but do you have any sense that the parameters you have in your model would indeed stay constant over time? In the sense that it's possible that, you know, controversiality dies off at some point, or like you know, is there any temporal variation that would be expected on the parameters of the model itself?
In which sense, sorry?
So for the model you're presenting, where you have your encoding with some parameters, controversiality, etc.
Yeah, sure, yes.
So my question was whether you would have some temporal variation of these parameters that could be due to the way a structure has changed of the network, that there would be also something governing like alpha in time, or so is there some way you can validate in a way alpha from other data, or show this parameter with another way maybe to show that they're
this is interesting. It's difficult. I mean, like, so there is this other paper which is called like quantifying controversialness. Now I don't remember exactly the title, but it's again from computer scientists, and they actually try to do that, right? Try to quantify controversial. The problem is that, as I said at the beginning, you should try to quantify that in a way which is independent from the network, which is independent from the opinion, and it's very difficult. Of course, it's very difficult. And on top of that, it could vary in time, right? I mean, like, not the controversialness of the top, also the controversialness of the topic, maybe. So it's all very difficult to measure. Even though, I mean, like, simple questions like, but so, like, people are more or less polarized now with respect to 10 years ago. Everyone tells you, yeah, sure, of course they are. But I mean, I didn't see real convincing evidence because it's so difficult. You should like take like a longitudinal study during 10 years. I mean, like the NS study, for example, the data that I presented in the last part, there are always more or less the same questions down to a random sample of people. So this could work. There are so many like other confounding factors to be taken into account. So it's, yes, of course, these are measuring controversialness would be like super interesting. But in this model, for example, it's just one parameter for the topic, which is not changing in time because otherwise there are too many things, right? The idea was to keep it quite simple with just three things, but yeah.
All right. Is there any other question in the room, in the virtual room? We're approaching the end, actually, of the.
I have a quick question, which is sort of similar to what Mark was asking, but it's also asking about a model. And it seems to me one of the important things in the model would exactly be the network between the people. What happens if you change your assumptions about the network? How robust is your model? It gives the results that make sense, but it doesn't mean it works like that.
Yeah, thanks. Yeah, exactly. This is one point we addressed it. So the idea is that the important feature of the model is that the opinions and the dynamics of and the networks co-evolve. So the idea is that while the opinions change, I had here a slide to show like what I don't have it here, to show the co-evolution of the opinions and the interaction. So the idea is that as the opinions evolves, also the interactions evolve because there is homophily, right? And there's this feedback loop between the opinions and the network, because the more the network becomes like polarized, the more it's easy for the people on one side to interact with the other. And this is really the key that gives rise to the polarization stuff. Because without this, you cannot see any real emergence of polarization. Either you put it like by hand, let's say, or otherwise you don't see it. So actually we tested it's robust with respect to the variation of the parameters defining the activity-driven model. So it doesn't matter if you take like a power law with exponent 2.1 or 2.5. The idea is that as long as the agents have an activity which is power law distributed, and as long as there is homophily, then again, it doesn't matter if it's like 2 or 3. It is that there is some strong homophily in the network, then the polarization emerges. Now, for example, here, if you start varying, for example, start varying the parameter alpha and the parameter k, then you can see like this phase transition, right? So depending on how much is k and how much is alpha, you will see like the emergence of polarization or consensus. But this is nice. We like it. What we wanted is that the model is robust with respect to the basic parameters. So the idea that for example, a network is activity driven with this homophily.
Thanks.
Thank you.
Yes, it's good. I think we're reaching the end of the time. It was really a great talk, really interesting. Thanks a lot, and thanks a lot also for everyone to join. Actually, we were quite a lot today, so that's really great. So